Good day, students. I welcome you all to another discussion for the subject construction materials and testing. And we are already on our fourth week now, the week after our midterm exam. So this will be our first lesson for the week. So for this week, we are going to talk about preparation and curing of concrete test specimen. So for this topic, we will be dealing provisions by ASTM with regards to preparation of concrete test specimen. Okay, so when we say preparation of concrete test specimen, naka-subdivide siya into two classifications. First is in the laboratory, or making and curing of concrete test specimen in the laboratory, and at the same time making and curing of concrete test specimen in the field. Okay, so duha na siya ka-classification. So both of this classification will be discussed sa kaning video recorded presentation. Okay, so first we talk about ASTM C192. Okay, so before we do that, so I guess everyone is already aware of what ASTM stand for. So that is American Society for Testing Materials. So most of those test procedures that we do or we incorporate there sa testing of materials is based on the provisions of ASTM. Okay, and then per procedure naka-denote na siya og kining code, So for the case of standard practice for making and curing concrete test specimens in the laboratory, ang iyang code is C192, and then kung sa field po siya, ang iyang code is C31. Okay, so both provisions under ASTM will be discussed here. Okay, so first we talk about ASTM C192, or the standard practice for making and curing concrete test specimen in the laboratory. So first we talk about the scope of this test procedure. So first is this practice covers procedures of making and curing test specimen of concrete in the laboratory under accurate control of materials and test conditions using concrete that can be consolidated by rodding or vibration as described herein. So what is inside the provision of ASTM C192 is all about the step-by-step procedure on how to properly make and cure your concrete test specimen in the laboratory. And not only that, also included in the provision of ASTM is the restrictions and limitations, and also mga specified specified values sa ato ang test procedure. Okay? So, expect nga very detailed yun ang mga provisions ni ASTM, especially sa kaninga kaninga ASTM C192. Okay? So for its significance and use, ang importance ani niya provision or kining standard practice or standard procedure is this practice provides standardized requirements for preparation of materials, mixing concrete, and making and curing concrete test specimen under laboratory conditions. If specimen preparation is controlled as stipulated herein, these specimens may be used to develop information for the following purposes. Okay, first, mixture proportioning for project concrete. Next is the evaluation of different mixtures and materials, and at the same time correlation with non-destructive tests and providing specimens for research purposes. So we are going to talk one by one. We are going to explain one by one ang kaninga mga significance. Okay, so first is the it is true this standard procedure or standard practice would be able to know the proper proportioning and then the ideal proportioning of your concrete or mga concrete component, which denotes to cement, fine aggregates, water, and if applicable, admixture. It is through this making and curing of test specimen in the laboratory we'll be able to determine proper proportioning or mixture sa kanyang concrete. Next is that, and also sa research purposes na siya, would be able to know the correlation rather with non-destructive test, because values or test results from these test specimens, so when tested after making and curing them, okay, so when I value ana when tested, so ang kanang value or ang mga data ana pwede nimo na siya i-correlate with each other and also with other tests, no, not only compression or bending test, no, for concrete test specimen, but also you can derive will be able to derive, no, equivalent values for those tests, no, from the test nga kaning concrete test specimen. Okay, so next importance or significance or use, no, of the standard procedure is we'll be able to provide, no, determine also specimens for research purposes. Okay, so especially those researchers nga that are trying to study, no, different variations of concrete. Now, say for example, kaning effect of fly ash as partial replacement of cement in PPC concrete, or effect on compressive strength of concrete by partial replacement of cement with fly ash, no? So, one of the data nga imong kailangan para ani nga mga research would be determined through the standard procedure ASTM rather, no, C192. Okay, so if you deal with this type of researches, rest assured, no, you will also be dealing with the standard procedure ASTM-C 192. Okay. Okay, so now we start tackling or discussing, no, parts by parts of what is inside ASTM-C 192 or standard practice for making and curing concrete test specimen in the laboratory. Okay, so first we determine, no, or we define the apparatus nga atong gamiton for this practice, no. So it is inside ASTM-C 192, no, ang mga apparatus that we are going to need. First is the molds, no. So we have here the concrete cylinder mold, no, and then the beam mold. Okay, no, concrete beam mold. Okay, so naay mga provisions din. I will not be reading that one. Basta kani siya nga mga provision kadiari pertains to the kanang sa mga molds, no, cylinder molds, and then kaning beam molds, no, kibalang yang provision in terms of kanang ihang quality, no, and also sa iyang mga fasteners, and then iyang mga dimensions, and then kailangan, no, specified man gud ang dimension sa cylinder, and then sa beam pod kailangan siya standard. Okay, so kibali kana ang mga provision are cited here. Okay. Next is the tamping rods. Okay, so ang kaning tamping rods will be used in the consolidation process. Okay, so when we say tamping rods, na ay duha ka klase, no, that we use in testing on making, no, curing and making and curing of concrete test specimen. Duha na siya, no, na ay larger rod and then the smaller rod. So, natay muna siya, no, ang mga sizes or dimensions sa larger rod and then sa smaller rod pod, no. Either we can use ani sa ilahang duha, no, basta lang nakasulod siya sa specific nga mga dimension niya, no, 16 mm diameter and then 10 mm diameter pod, and sa length pod is 600 mm and then 300 mm. Okay, so kailangan pag magamit ka og rod dapat either lang aning duha. Okay, based na siya sa ASTM as well. Next is you are going to need, no, rubber mallet, no, for consolidation process gihapon ni siya. So na siya specific weight gihapon, no, that ranges 0.6 to 0.2 to 0.6 kilogram. No, dapat within that range lang, no, within that weight range lang ang ato ang gamiton ang rubber mallet. Okay, for consolidation process gihapon ni siya. Okay. Next is we have vibrators, no. Ang kaning vibrators is for consolidation gihapon ni siya. So when we say vibrators, duha ka klase, no, at ang vibrator na dihang internal vibrator and then external vibrators. And as to the sizes, no, and dimensions of these vibrators, naka-specify gihapon siya dire, no. I will not be reading that one na. Okay, so for the internal vibrator, ang iyahang frequency, no, sa pag-vibrate niya should at least be 7,000 vibrations per minute. Okay, and then for external vibrators, medyo ano siya, no, 3,600 vibrations per minute lang ang iyahang frequency. Okay, so kailangan when you use external vibrators or internal vibrators for consolidation ni siya nga process, ha, kailangan nakasulod siya ani nga specification. Okay? So if wala siya nakasulod ani nga specification, dili nimo siya pwede gamiton. Okay, ana lang. Next is small tools, no? Like shovels, pails, mga trowels, mga float, no, mga gloves, and then mga straight edge, no? You will also be needing those. Okay? And also, you will also be needing, no, this lamp apparatus, no? So, kahibaw naman ta kung unsay purpose aning lamp apparatus, no? It is used to determine the workability of concrete. Okay? Next is we are also going to need sampling pan or mixing pan. Okay? Na as to the sizes or the appearance, no, nagyapon tay specification ana, and then kailangan once we use sampling or mixing pan, kailangan ang iyang specification is nakasulod gyapon aning provide ni ASTM, and if wala, dili siya pwede gamiton. Okay? Next is the wet sieving equipment, no, kaya siya nga equipment diari, it can be found in the laboratory as well. Okay? And then, ang provision yan, no, in terms of the specification of this equipment or this wet sieving equipment is makita siya sa Practice C172. Okay? Still under ASTM na siya. Okay? Next is the air content apparatus. Okay? This apparatus is for measuring of air content, no? And it shall conform to the requirement test method C231 or 173, still under ASTM. No? So when you use this equipment or this apparatus, it should conform, no, to the specifications under C231 or C173. Okay? Next apparatus is the scales, no, or timbangan niya siya. Okay, so scales are used for determination of mass of batches of material and concrete, no, and it should be accurate within 0.3% of test load. Okay na siya accuracy ng 0.3%. Next is the time measuring devices. Okay, nagyapon siya provision, no, in terms sa paggamit, no, ani, and also sa requirements pod ani nga device which is under test method C1064. Okay, still under ASTM. And of course, you will be needing, of course, no, concrete mixer. It is a power-driven concrete mixer, shall be a revolving drum, tilting mixer, or suitable revolving pan or revolving paddle mixer capable of thoroughly mixing batches of the prescribed sizes at the required slump. Okay? So, mo to siya, no, those are all the apparatus and equipment that you are going to need, no, as you do the procedures for standard practice for making and curing concrete test specimen. Okay, so as you do this standard procedure, no, as you do this standard practice, kailangan you will be able to complete those apparatus and equipment, no, and also if not, na yung mga equivalent nila, which would be okay gihapon as long as ang kanang mga provision or mga specifications sa equivalent apparatus or equipment, ano gyapon siya nakasulod gyapon siya sa provision sa ASTM standard. Okay? So next we go sa preparation of materials. Okay? So before we start the making, no, of concrete test specimen, kanang mga materials that we are going to use, no, sa ato ang concrete mixture, it shall be kining it shall be maintained, no, at temperature 68 to 86 degrees Fahrenheit or 20 to 30 degrees Fahrenheit, no. So kailangan i-check nimo dili pwede init ang imong mga aggregates, dili pud pwede nga basa kaayo imong mga aggregates, no. Ana lang siya, so kailangan all kanang mga materials that you would incorporate dito sa imong concrete mixture should be maintained at temperature stipulated here, no, sa provision by ASTM. Okay? Next is for cement, no? So before we incorporate cement dito sa ato ang concrete mixture, kailangan you have to remove all the lumps, no, or kanang mga unnecessary nga mga materials nga pwede masagol diha sa ato ang cement. So kailangan pure cement siya, or para to make sure, no, as stipulated here in ASTM provision, it shall be passed through number 200 sieve or finer nga sieve, no. So kung ano ka kanang if kay na bitong questionable ang quality sa imong cement, no, though it is provided here sa ASTM provision na kailangan i-store nimo siya in a dry place, no, or moisture proof container. So if dili ka sure sa quality sa imong cement, please do sieving, no. Kailangan i-pass nimo siya, kailangan mo pass ang imong mga cement particles sa number 200 sieve or finer sieve, no, para for us to be able to get rid of the lumps or any kanang mga unnecessary materials. Okay? Next is for the aggregates. Okay? So before we incorporate aggregates diha sa ato ang concrete, no, nga test specimen, no, as we make our concrete test specimen, before nato incorporate ang aggregates, kailangan na test na siya, no, sa kanang mga preliminary test atong ginaingon. Unsa man yung mga preliminary test, this includes the specific gravity and absorption. Kailangan na determine na siya, no, through ASTM provision gihapon nagapantay standard practice ana, no, in the determination of specific gravity and absorption capacity of our aggregates. And at the same time, kailangan atong i-measure ang moisture content sa atong fine aggregates, no, and also the surface moisture content for fine aggregates. So kailangan before nato incorporate ning both fine and coarse aggregates diya sa atong concrete mixtures, no, as we make our concrete test specimen, kailangan niagi na sila or naka-undergo na sila og mga preliminary testing. Okay?
Okay, now same goes with lightweight aggregates as well, no? But most importantly for lightweight aggregates, we really have to determine, no, ang iyahang moisture content or yung moisture characteristics, because these lightweight aggregates are considered highly porous and highly absorptive siya, no? So given that, so maka-absorb siya water, no, when mixed with concrete, no, together with water and cement, no. So it is really very important to determine, no, the moisture content of these aggregates at the time of mixing, because it would really, no, incur effects on the properties of the freshly mixed concrete and hardened concrete, such as slump loss, no, and compressive strength, and also to resistance to freezing and thawing. Okay. Okay, next is for admixtures. Okay, we use admixtures in our concrete mixture, no. One of the reason as to why we do that one is because we want to manipulate, no, the time setting of our concrete, no. It's either we want to fast track the time setting of our concrete, so pasabot ka ng dali ra siya mugahi, no, dali ra siya mo solidify, dali ra siya mo set, no. And at the same time, on the other hand, no, we also use admixtures if we want to lengthen the time setting of our concrete, no. Kaya bali i-delay na to ang iyahang pag-harden or pag-solidify. Okay, that is the main usage of admixtures. Okay, so when we say admixtures, naa siya duha ka klase, no. Ang actually tulo na ay powdered nga admixture nga insoluble siya, which mean dili siya ma-dissolve sa water. Napud tay powdered admixture nga nga soluble siya, no, so pwede siya i-mix sa water. At the same time, if not powdered, naatay ka ng liquid na no nga admixture. Okay, for the case for all of those types of admixtures, no, naatay standard nga procedure, no, or practice, no, kung unsaon siya pag-mix diha sa atong concrete mixture. Okay, for the case of powdered admixtures that are entirely or largely insoluble, that do not contain hygroscopic salts and are to be added in small quantities, it should be mixed with a portion of cement before introduction into the batch in the mixer, so as to ensure thorough distribution throughout the concrete. And essentially insoluble materials which are used in amounts exceeding 10% by mass of cement, such as pozzolans, should be handled and added to the batch in the same manner as cement. Okay. Powdered admixtures, which are largely insoluble but contain hygroscopic salts, may cause balling of cement and should be mixed with the sand. Okay, and for the case of water-soluble and liquid admixtures, it should be added to the mixer in solution in the mixing water. The quantity of such solution used shall be included in the calculation of the water content of the concrete. Okay. Now we proceed to the testing procedures no, of this standard practice for making and curing concrete test specimens in the laboratory. Okay, so we are done discussing the apparatus and equipment so that we are going to need no, for the test procedures as well as the preparation of the materials. So we are all done discussing all the provisions and also standard practices but in terms of those components. Now we proceed to the test procedures na, no? So first is mixing of concrete, okay? So the general note, so mix concrete in a suitable mixer or by hand in batches of such size as to leave about 10% excess after molding in the test specimen. Hand mixing procedures are not applicable to air-entrained concrete or concrete with no measurable slump. Hand mixing should be limited to batches of 1/4 cubic foot in volume or less. Okay, so there are two methods no in mixing our concrete. So na diha ang machine mixing or mixing through the use of machines or equipment, and at the same time katong hand mixing no manual na siya nga mixing by the use of hand. Okay, so both method or both procedure na siya step by step standard procedures provided by ASTM. Now for the machine mixing, first is prior to starting rotation of the mixer and add the coarse aggregate, some of the mixing water and the solution of admixture. When feasible, disperse the admixture in the mixing water before addition. Now you start the mixer, then add the fine aggregate, cement and water with the mixer running. If it is impractical for a particular mixer or for a particular test to add the fine aggregate cement and water while the mixer is running, these components may be added to the stopped mixer after permitting it to turn a few revolutions following charging with coarse aggregates and some of the water. Next, you mix the concrete after all ingredients in the mixer for 3 minutes followed by a 3-minute rest followed by a 2-minute final mixing. Now you cover the open end or top of the mixer to prevent evaporation during the rest period. Take precautions to compensate for moisture retained by the mixer so that the discharged batch, as used, will be correctly proportioned. Next, to eliminate segregation, deposit machine-mixed concrete in the clean, damp mixing pan and remix by shovel or trowel until it appears to be uniform. Now, the standard procedure no, for hand mixing of concrete. First, you mix the batch in a watertight, clean, damp metal pan or bowl with a bricklayer's blunted trowel, using the following procedure when aggregates have been prepared. Next, you mix the cement, powdered insoluble admixture if used, and fine aggregate without addition of water until they are thoroughly blended. Next, add the coarse aggregate and mix the entire batch without addition of water until the coarse aggregate is uniformly distributed throughout the batch. Next, you add water and the admixture solution if used, and mix the mass until the concrete is homogeneous in appearance and has the desired consistency. Next, if prolonged mixing is necessary because of the addition of water in increments while adjusting the consistency, discard the batch and make a new batch in which the mixing is not interrupted to make trial consistency tests. Okay, now that you are done no, mixing the concrete, now we proceed to the determination of these factors, no, which is the slump, the air content, the yield, and the temperature. Okay, for slump, so you measure the slump of each batch of concrete immediately after mixing in accordance with test method C143 or C143M. Now for determination of air content, determine the air content when required in accordance with either test method C173 or C231. Okay, so test method C231 should not be used with concretes made with lightweight aggregates, air-cooled blast furnace slag, or aggregates of high porosity. Discard a concrete used for determination of air content. Okay. Next is for determination of yield. No? So determine the yield of each batch of concrete if required in accordance with the test method C138. Okay, so concrete used for slump and yield test may be returned to the mixing pan and remixed into the batch. Now for the temperature determination, you used standard procedure set forth no, by ASTM in test method C1064. Okay. Now after you have mixed the concrete and now you have already determined the yield, the air content now and the slump, now you proceed to making the samples. Okay, so first step in making the samples is the place of molding. Okay, you mold specimen as near as practicable to the place where they are to be stored during the first 24 hours. So if it is not practicable to mold the specimen where they will be stored, move them to the place of storage immediately after being struck off. Place molds on a rigid surface free from vibration and other disturbances. Avoid jarring, striking, tilting, or scarring the surface of the specimens when moving the specimens to the storage place. Next is for the placing. Okay? So after na-prepare nimo ang mga molds no wherein imo siyang ibutang sa lugar nga dili siya matandog no free from any vibration or disturbances in general, now you place the concrete mixture no into those molds. Okay? Place the concrete in the molds using a scoop, blunted trowel, or shovel. Select each scoopful, trowelful, or shovelful of concrete from the mixing pan to ensure that it is representative of the batch. It may be necessary to remix the concrete in the mixing pan with a shovel or trowel to prevent segregation during the molding of specimens. Okay, so next. Now, when placing your concrete mixture no, inside your mold, it should be done by layer. Okay, dili siya pwede nga kasaon nimo siya butang. So it should be done by layer, and then the number of layers is determined depending on the diameter of your cylinder mold. Okay, so we have here a table no, still under ASTM C192. So number of layers required for specimens. So we have here sizes no of your cylinder in terms of diameter and at the same time mode of consolidation and the numbers of layers na, of approximate equal depth. So if you have, say for example, no, 4 inches or 100 mm nga diameter sa imong cylinder mold, then that would mean na based on this table, you will have to place or put your concrete mixture inside your mold into 2 equal layers. Okay, and if 6 inches no, or 150 millimeters ang diameter sa imong cylinder, then it would mean nga tulo ka equal layers ang pagsulod nimo or pag-deposit nimo no sa imong concrete mixture dito sa imong mold. Okay, and so on na siya. Okay, so what we usually use is the concrete cylinder with a diameter of 6 inches or 150 mm, which mean the number of layers that we usually use no diha sa pag-create nato sa ato ang concrete specimen is 3 layers na siya with equal depth. Okay, so here are the methods of consolidation. Okay, so after you have already deposited or after you have put no your concrete mixture diya sa imong mold, now you proceed to the next step which is the consolidation. Okay, so we do consolidations to omit or get rid of those voids that are inside your concrete mixture no because it is not very ideal to have voids within no, your concrete mixture because it would affect not only the strength but also the um, durability no, of your concrete. Okay, so for methods of consolidation, it can be done by rodding, either rodding, internal or external vibration. Okay, so you rod or vibrate concrete with slump greater than or equal to 1 inch or 25 mm. Vibrate concrete with slump less than 1 inch. Do not use internal vibration for cylinders with a diameter less than 4 inches or 100 mm, and for beams or prisms with breadth of depth less than 4 inches. Okay, for rodding, so you place the concrete in the mold, no, in the required number of layers, right, of approximately equal volume. Rod each layer with the rounded end of the rod using the number of strokes and sizes of rod. Um, Rod the bottom layer throughout its depth. So distribute the strokes uniformly over the cross-section of the mold, and for each upper layer, allow the rod to penetrate through the layer being rodded and into the layer below approximately 1 inch. Okay, so after each layer is rodded, tap the outsides of the mold lightly 10 to 15 times with a rubber mallet to close any holes left by rodding and to release any large air bubbles that may have been trapped. So this basically means that, diba, previously we have mentioned that as you place or as you deposit your concrete mixture into your mold, it should be done in layers, diba, depending on the diameter of the cylinder mold, ang iyahang number of layers. And then, say for example, 6 inches ang diameter no sa imo ang cylinder. So that would mean na based sa katong table, you will have 3 layers no of equal depth and somehow equal volume no of concrete. Now, every after layer is deposited into the mold, kailangan nimo siya i-rod, no? Kibali, magamit ka atohang either large rod or small rod. So, kibali imo siyang i-poke, no? Ang katong imuhang layer, no? Actually, ang kanang pag-poke nimo or pag-stroke nimo, no? Sa rod diha sa imuhang layer, nana siya a specific number. So, aton siya i-discuss later. And then, after nimo siya i-rod, no? So, bali, first layer, i-rod nimo siya. And then, second layer, i-deposit na pod nimo. So, ano na sad na nimo, imuha na sad siyang i-rod, no? So, ang katong imuhang layer, so second layer, pag rod nimo, kailangan mo pass through ang imuhang rod dito sa kuan kanang iyahang murag gani kibali ipalahos nimo siya og 1 inch no sa katong layer nga naa sa iyahang ubos. Okay, and after that one, no, you then tap the outsides of the mold lightly lang no 10 to 15 times with a rubber mallet para since naman to pag stroke nimo nun ay mga mabilin nga mga bangag-bangag kay ano man to siya kanang dako man imuhang imong rod, di ba, na siya is either 16 mm or 10 mm. So, pag stroke anak nimo dito ay mabilin nga mga holes. So, that is why imo to siyang i-omit or we get rid of those holes no left by the rods. So, kailangan ato siyang tap ang outside sa mold o rubber mallet 10 to 15 times. Okay? So here is a table, no, diameter of rod and number of roddings to be used in molding test specimen. So this basically kini siya nga table no has kining columns for diameter of your cylinder mold and then kining diameter of rods that you are going to use no and then also at the same time na siya corresponding number of strokes per layer. Okay, say for example we have 6 inches diameter na cylinder or 150 mm. So the diameter of the rod that we are going to use for consolidation is 16 mm no or 5/8 inches no and then di ba based sa atong pikas nga table pag 6 inches ato ang diameter sa ato ang cylinder no tulo siya ka layer so tulo siya ka layer and then ang gamit nato pag consolidate sa iya is 16 mm rod so every layer should be kailangan siya i-stroke siya no or kailangan nimo siya i-rod 25 times per layer. Okay, bali, that is 75, no? 75 strokes. All in all, 25 strokes per layer. Okay. Next type of consolidation, no? Katong gainin na is rodding man to siya. Karon is vibration. Now, for vibration, you fill the molds and vibrate in the required number of approximately equal layers. No? You place all the concrete for each layer in the mold before starting vibration of that specific layer. Okay? So when you say vibration as a mode of consolidation, duha ka klase, no? Ang atong vibration that is internal vibration and external vibration. Okay? For internal vibration, you insert the vibrator slowly and do not allow the vibrator to rest on or touch the bottom or sides of the mold or strike embedded items such as strain meters. Slowly withdraw the vibrator so that no large air pockets are left in the specimen. And same lang gihapon no sa rodding no nga iyahang number of vibrator insertions per layer is determined also by the diameter of the cylinder. Okay, so so for example, kung nakay 6 inches nimo nga diameter nga cylinder mold, then you will have to insert 2 times no your vibrator diha sa imuhang layer sa imong concrete per layer na siya. Okay, so kibali kung nakay 6 inches, tulo man to siya ka layer, di ba? Sa 6 inches. So, per layer, ikaduha ka mag-insert sa imong vibrator. So, that would mean 6, no? Total insertions per layer. So, same na gihapon siya sa rodding, no nga. Kailangan ni may ipa-overlap og 1 inch or at least 25 mm no dito sa surface in between layers no kailangan ipalapas nimo siya. At the same time, after no ipang-insert nimo ang imong vibrator for consolidation, you will need no to tap the outside of the mold at least 10 times by the use of a rubber mallet. Okay? So, kato siya nga provision is for cylinder molds, no? Now for kining mga beam molds, no? Insert the vibrator at intervals not exceeding 6 inches or 150 millimeters along the center line of the long dimension of the specimen or along both sides, but not in contact with the strain gauge in the case of crypt cylinders. Okay, so lahi siya. Di kato nga table ka ganina is applicable for only cylinder molds. Okay, so for specimens wider than 6 inches or 150 mm, use alternating insertions along two lines. Allow the shaft of the vibrator to penetrate into the bottom layer approximately 1 inch or 25 mm gihapon siya. No? So every after each layer is vibrated, you need to tap the outside of the mold sharply at least 10 times with a rubber mallet gihapon no. So to close holes left by the vibrator no. Next type of consolidation under vibration is external no nga vibration. So when external vibration is used, take care to ensure that the mold is rigidly attached or securely held against the vibrating element or vibrating surface. So after nimo ma-consolidate no by the use of rod or vibrators, if you will have to do now the finishing. Okay, so now you need to strike off the surface of the concrete and float or trowel it in accordance with the method concerned. So if no finish is specified, finish the surface with a wood or magnesium float. Perform all finishing with the minimum manipulation necessary to produce a flat, even surface that is level with the rim or edge of the mold and which has no depressions or projections, rather larger than 1/8 inch or 3 millimeters. Same ra gyud gihapon siya no for finishing procedures for your cylinder molds. Okay? And then for the horizontally cast crypt cylinders, mo gihapon ni siya na ang method sa iyang finishing. Okay? So next after no na mo ma-mix ang concrete and then ma-deposit sa mold and then ma-consolidate and then ma-finish siya no, we can now proceed to the next no part sa sa kaning standard practice no ASTM C192, which is the curing na of your concrete test specimen. Okay, so when you say curing, na siya initial curing and also final curing. Okay, for the initial curing, to prevent evaporation of water from unhardened concrete, cover the specimens immediately after finishing, preferably with a non-absorptive, non-reactive plate or a sheet of tough, durable, impervious plastic. So, kailangan nimo siya i-cover. No? So, specimens shall be stored immediately after finishing until the removal of the molds to prevent loss of moisture from the specimen. Okay? Okay, so muna lang siya for initial curing na you need to cover your fresh concrete or unhardened concrete with non-absorptive, non-reactive plate or sheet, no, and also you can also use no wet burlap as well. Okay, para lang na siya to prevent no evaporation of moisture diha sa imuhang unhardened or fresh concrete. Okay. Now, after the initial curing, 24 to 32 hours, from casting or from the making of your concrete test specimen, pwede na mo siya i-remove from the mold. Okay? So, what's gonna happen after you have removed, the specimens from the mold? Okay, so unless otherwise specified, all specimens shall be moist, cured at 73.5 plus 3.5 degrees Fahrenheit, or 23, degrees Celsius plus minus 2 degrees, from the time of molding until the moment of test. The storage during the first 48 hours of curing shall be in a vibration-free environment. As applied to the treatment of demolded samples, moist curing means that the test specimen shall have free water maintained on the entire surface area of all times. This condition is met by using water storage tanks or a moist room in accordance with the requirements of specification C511. Cure structural lightweight concrete cylinders in accordance with specification C330. So what's going to happen after you have demolded your concrete specimen, or after you have removed, your concrete specimen from the mold, is you are going to put it, diha sa water storage tank, and then kailangan makover gid na ang iyahing entire height, sa imuhang cylinder, or sa entire nimo nga specimen or cylinder ba or beam, kailangan ma-covered siya o ganang water jud, diha sa imuhang water storage tanks, because ano na siya, that is to really maintain ang kanang temperature niya sa imuhang specimen. Okay. Now, for the case of flexural strength nga specimen, or kanang imong beam nga concrete sample, cure the flexural strength test specimen in accordance with initial curing and removal from molds, except that while in storage for a minimum period of 20 hours immediately prior to testing, they shall be immersed in water saturated with calcium hydroxide at 73 plus minus 3 degrees Fahrenheit. At the end of the curing period, between the time the specimen is removed from curing until testing is completed, drying of the surface shall be prevented. Okay, so that's all for the provisions, under standard practice for making and curing concrete test specimen in the laboratory. Okay, so mo to siya yung last procedure. Now we go to the discussion of the provisions under ASTM C31, or your standard practice for making and curing concrete test specimen in the field. Now, for the scope of ASTM C31, or your standard practice for making and curing concrete test specimens in the field, this practice covers procedures of making and curing cylinder and beam specimens from representative samples of fresh concrete for a construction project. Okay, so the concrete used to make the molded specimen shall be sampled after all on-site adjustments have been made to the mixture proportions, including the addition of mixed water and admixtures. This practice is not satisfactory for making specimens from concrete not having measurable slump or requiring other sizes of or shapes of specimen. Okay. Now, for the significance and use of ASTM C31, this practice provides standardized requirements for making, curing, protecting, and transporting of concrete test specimen under field conditions. Okay? So, basically, ang katong ASTM C192, ang iyahang usage or yung significance is taman lang sa making, curing, and also katong actually tama na siya sa curing, but whereas ang kaning ASTM C31 is naa siya provisions on protecting and transporting your concrete test specimen under field conditions. Okay, mo na siyang difference between ASTM C192 and C31, ang iyang coverage, because again, ASTM C192 is only up to curing lang, of concrete test specimen, and then prior to testing, whereas ang C31 is na siya making, curing, protecting, and transporting, since the field man siya towards the laboratory. Okay, so if the specimens are made and standard cured as stipulated herein, the resulting strength test data when specimens are tested are able to be used for the following purposes. Okay, it will be the basis of acceptance, no, of testing for specified strength, and at the same time, it can be used for checking adequacy of mixture proportions for strength, and of course, on top of it is the quality control, no, ang kanang quality of concrete nga atong gigamit diha sa site or diha sa field. Okay, so kibali mo na siya. So as to the apparatus, so kibali same lang ang components, no, same ang ASTM C31 at the same time same ang ASTM C192. So nalang mga slight differences, pero in general and especially on the apparatus and equipments to be used, almost similar siya, no, for the molds. So ang ihang provision din ani for molds is almost the same siya dito sa ASTM C192. Okay, same with tamping rods, no? Murag gihapon ni siya. Same ra gyapon ni dito, di ba? If we have a 6 inches cylinder, we are going to use 16 mm diameter rod. So na siya yung murag tolerances diri, no? Plus minus 2 mm. Okay? And also for kanang consolidation nga tools, no, or equipment, we use here vibrator. So we don't use na rod. Okay? Ang then ang imong capacity or imong frequency sa imong vibrator is 9,000 vibrations per minute. Okay. Next is same maghapon siya, no, for rubber mallet. And also your placement tools, which includes your shovel and your scoop, no. Kibali gamiton nimo pag fill nimo sa imong mga molds, ano, with concrete mixture. Next is you're also going to need fishing tools, no, such as float or a trowel, and of course ang slump apparatus, no, dili siya mawala, and also sampling receptacles, okay, which includes sa kanang imong pan or kaning isa, no, wheelbarrow. So same ra gihapon, no, for air content apparatus, time measuring devices, same ra gid gihapon. And now for the testing requirements, na siya'y provision di are, no, as to the dimension of your mold, no, or lagi testing requirements with respect to the dimensions of the mold, no. So yeah, for the case of cylindrical specimen or concrete cylinder samples, no, ang imong cylinder could be either, no, 150 by 300 mm or 6 by 12 inches, or 100 by 200 mm or 4 by 8 inches, no. Dimension na siya sa imong cylinder mold. Okay. Next for beam specimens, no, na ay tay kuan di ari kanang iyahang table, no, summary naman ni siya under ASTM C31 gihapon ni siya. So we have here a column, no, for your NMAS or nominal maximum aggregate size, and then also your minimum cross-sectional dimension. Okay, so kibali ang imong cross-sectional dimension sa imong beam mold nga imong gamiton nagadepende siya sa nominal maximum aggregate size. Okay, for 1 inch, no, or 25 mm nga NMAS, you are going to need 100 by 100, no, cross-sectional area sa imuhang beam nga mold, and then kung greater than 25 siya, no, 150 by 150. Okay, and also as at one kanang difference, no, sa provision sa ASTM C192 and ASTM C31. ASTM C31 nga provision is naa siya'y specification or standard, no, as to the field technicians. Okay, the field technicians making and curing specimens for acceptance testing shall meet the personal qualification requirements of practice C1077. Okay. Now we proceed to the molding of specimen, no. First is the place of molding. So same ra gyud gihapon sa ASTM C192. Your mold shall be placed in kanang surface siya or environment wherein free siya from vibration and also disturbances, no, in general. Now, after you have placed your mold in a kining dili siya ma-disturb nga place, no, you are now ready to cast your cylinder samples or to make your concrete cylinder samples. Okay, so as to the rodding or vibration nga methods, we refer here, no, sa kaning table. Now, so as you cast, kani siya ka table, no? So as you cast cylinder nga sample, natay table 3 diri, no, wherein you are going to choose from those two nga mode of consolidation, no? So magdepende na siya sa slump nimo. Okay, kung 25 millimeter ang imuhang slump, or 1 inch na sa you're going to use rodding or vibration. So, otherwise, kailangan ka mag-use of vibration yun. Okay? Next is the table 4, so molding requirements by rodding. So, this would mean kung kapila nimo siya i-rod, no? Kung pila ka times nimo siya kailangan i-strike, no? So, again, magdepende na siya sa diameter size ng cylinder, and at the same time, dependent, no, sa diameter sa imong cylinder, ang number of layers of approximately equal depth, and at the same time, number of roddings per layer. Okay? So, almost same ra gid gihapon siya sa ASTM C192. Okay? Next, and also the molding requirements by vibration, no, if you're going to use a vibration as a method of consolidation. Okay? Naka dire cylinder, no, nga diameter in terms of millimeters or inches, then naka number of layers, no, nga imuhang pimita na sa pagdeposit sa imuhang concrete diya sa imong cylinder nga mold, and the number of vibrator insertions per layer, and approximate depth of layer. Okay, nagyapon na diya. Next is now we proceed to casting of beam samples. Okay. So you determine the number of roddings per layer, one for each 14 square centimeter, na, of the top surface area of the beam. Okay, mo na siya ang iyahang number of roddings per layer. So we proceed to consolidation. So the methods of consolidation for this practice are either rodding or internal vibration. Okay. Now for rodding, same ra gyud hapon siya, no, sa katong ISTM C192. Okay. And also sa kaning iyahang vibration. Now, ang finishing, no, after ma-consolidate mo yung mga concrete mixture diya sa mold, you are now ready for finishing. Okay, so perform all finishing with the minimum manipulation necessary to produce a flat, even surface that is level with the rim or edge of the mold and that has no depressions or projections larger than 1/8 inch. Okay, so same ra gyud gihapon siya sa ASTM C192. Okay. Now, one difference also, no, sa ASTM, or one distinction sa ASTM 31 against ASTM 192 is yung provision for identification. Now, you need, no, to mark this specimen to positively identify them and the concrete they represent. Okay, so use a method that will not alter the top surface of the concrete. Do not mark the removable caps. Upon removal of the molds, mark the test specimen to retain their identities. Because, diba, as we have discussed, pod, you are to obtain multiple samples, no, of your concrete or cylinder or beam, no, as you go through the construction phase. So daghan gyud kag samples ana, no. So for you to be able to identify, no, and also ma-identify nimo kung unsa ang iyang gi-represent ani niya nga sample, so kailangan magbutang kag mga markings dira. But dili lang basta-basta nga mga markings, no, but you also have to make sure that these markings do not alter through time, no. Next is for curing. For the storage, so ang sa curing, no, almost same ra jud gihapon siya sa ASTM C192. Okay. So, one distinction gihapon no sa ASTM C31 against ASTM C192 no kay ang iyang provision sa transportation of specimens to the laboratory no since we are dealing with provisions under field conditions. Okay, so specimens shall not be transported until at least 8 hours after final set. Okay, test method C403 or C403M. Now, during your transporting, protect the specimens with suitable cushion material to prevent damage from jarring. During cold weather, protect the specimen from freezing with suitable insulation material. Prevent moisture loss during transportation by wrapping the specimen in plastic, wet burlap, or by surrounding them with wet sand or tight-fitting plastic caps on plastic mold. Transportation time shall not exceed 4 hours. Okay, so that concludes our discussion for this morning, which is about ASTM C192 and ASTM C193, no, standard practice for making and curing concrete test specimen for both laboratory and in the field. Okay, that would be all. These are the list of references now that I have used in creating this lecture notes. Okay, so I'll see you next meeting. That's all. Have a good day.